All right, welcome back to Applications of Calculus 2. We're going to keep talking about some derivatives here. So we talked about the power rule last time and exponentials and logarithms. So today we're going to talk about the product rule. The quotient rule. Okay. Most, I think we're talking about those. Yeah. So remembering the product rule is if you have an F times a G, okay, or some books use a U times a V, okay, and we want to take the derivative of these two things that got multiplied together, it's not just going to be the derivative of the first and the derivative of the second. We have to say something like the derivative of the first, that's the little tick, times the second, plus the first, times the derivative of the second. If you use F's and G's, it's going to be derivative of the first one times the second, plus the first times the derivative of the second one. Okay, so that happens quite often, and we use product rule quite a lot in this class. There's also quotient rule. So for quotient rule, okay, we're going to have like an F over a G. Okay. Let's set this up. So I want F over G tick, and I'm going to take the derivative, or just with different letters, U and V. Okay. So again, it's going to be derivative of the first times the second minus the first times the derivative of the second, all divided by the second one squared. Okay. For using these, derivative of the first times the second minus the first times the derivative of the second, all divided by the second one, the one on the bottom squared. Now, one nice thing about the product rule is that you can memorize it in the opposite order, and it doesn't really matter because pluses, like, it doesn't matter. 2 plus 3 is the same as 3 plus 2. But with the quotient rule, you have to be careful because there's a minus in there. And if you get the order messed up, you're going to get the wrong answer. Okay, so it's a thing you have to be really careful about when you're applying when you're applying the quotient rule. A lot of times with the quotient rule, what I will do is instead of doing the quotient rule, I will say, okay, well, that's just G raised to the negative one power, and then take the product rule with F times G raised to the negative one. So that's going to be derivative of the first times the second. Okay, so it's the derivative of the first function, 1 over the second function, plus the first times the derivative of the second, but you have to apply the chain rule. So it's going to be negative 1 G to the negative 2 times the chain rule, which is going to be G tick. Okay, so with a little bit of algebra, it actually will show back up to being this original function here, but that negative sign will float through, so it'll be the same idea. But that's pretty much how that's going to be working. Okay, so we have to be careful about if you're going to be if you have to employ the quotient rule, just be careful that you're getting the right order. But again, there's a little bit of a trick where if you take the bottom function, and make it to the top, but put a negative 1 for exponent, or put a negative on the exponent, you're going to be able to get around having to know the quotient rule exactly. Okay, so let's do a couple of examples here just to kind of warm this up. So if I want to take the derivative of, I've got, let's say x squared e to the, we'll say x over 3. Okay, and I want to take the derivative of x squared e to the x over 3. So what we're going to have to do is we're going to take the derivative of the first one. Okay, and I'm just going to leave it in the box, in my brackets, little boxes, saying I haven't taken the derivative yet. So we want the derivative of the first times the second, x over 3, plus the first x squared, okay, times the derivative of e to the x over 3. And I haven't taken that derivative yet, okay? So let's go ahead, and now we have a plan. Let's go ahead and implement those plans. So if I go ahead and take the derivative of x squared, we end up with 2x. I didn't touch this, e to the x over 3, one little bit. Plus, now we're moving on to the second part of it. The second part says first times the derivative of the second. So the second rather is going to be x squared. And now I need the derivative of e to the x over 3. That's going to be e to the x over 3 times, and now I need the chain rule of what's the derivative of x over 3 here, right? That's going to be x over 3. So let's go ahead and do that. We're going to say this is 2x e to the x over 3 plus x squared. e to the x over 3 times 1/3 times x. Okay, because oh no, I'm sorry, no x, just times 1/3, because the derivative of x over 3 is just going to be 1/3. So let's go ahead and simplify this down a little bit. We have 2x e to the x over 3, plus we have 1/3 x squared e to the x over 3. All right, and that would be my answer for the derivative of x squared e to the x over 3. All right, so that's not too bad. Now let's try one that's a quotient rule. So we can go ahead and do that. So we want to take the derivative of, let's go have a look at natural log of x divided by x. So again, I'm going to write down my plan, and then I'm going to go ahead and implement it on the next line. Okay, so I want derivative of the first. So I have natural log, the derivative of the top, tick, I haven't taken the derivative yet, times the second function, which is just x, minus the first, that's going to be natural log of x, times the derivative of x, and we're going to all divided by the bottom one squared. Okay, so let's go ahead and figure out what that's going to do for us. So the derivative of natural log is 1 over x, and we're going to say times x. Okay, minus, and now I have natural log of x times the derivative of x, which is just going to be 1. And we're just going to have a x squared here, okay, on the bottom. So let's go ahead and simplify this down a little bit. So we have 1 over x times x. That's just going to give us 1 minus the natural log of x all over x squared. And that's really all you can do with this. Now, I'll tell you the same little pep talk I give all of my classes for this, all of my calculating applications of Calc 2 classes, is that, okay, you may have been the friend who was not so good at math for your whole life. That's a lot of biology majors. I noticed that, like, I don't know that math very well. And yes, compared to an electrical engineering major, you're probably not going to be quite as good as they are. However, you have finished Calculus 1, and with luck and a lot of hard work, you are going to finish Calculus 2. You are no longer the friend who is not good at math. Okay, you actually have to take the responsibility of, yes, you know how to do math, and you're good at it. Okay, so the sooner you can embrace that reality, the better. Okay, I will tell you that one of the questions you will have more than anything else is you'll say, you'll have a friend who's like, x over 5, is that the same as 1/5 x? Yes, it is. X over 2 is the same as half x, all of those things. You will answer this question more than anything else because people don't get this question through. You know, if you only got to algebra 1, college algebra, you would probably have problems with this. Okay, you have gone past algebra, so technically you should be able to be good at this kind of translation. Okay, same idea. Square root of x next to the 1/2 power. You need to be good at being able to do that. Okay, so yes, I hate to be the bearer of bad news. You are no longer allowed to be the friend that is bad at math or the friend who is good at math. People come to you with math questions. Don't be ashamed to say, I don't know how to do that, because I have to say that. Okay. It's for fewer things, but I still have to say that. There are things my friends tell me, like, hey, can you remember this? I'm like, no, I never took that, and I have no idea what this is. Like, that's okay. I'm not going to feel ashamed about it. We're just going to say, be honest about it. But you're no longer allowed to be the friend who is not good at math. You have to be the friend who's good at math now. So with that little pep talk, I'm going to go ahead and sign off. So I'll say thank you for watching the video, and I will see you in the next one.